Hi, my name is Sudhir Sheth, Principal Solutions Architect at AWS.
Hi, my name is Awais Khan, Principal Solutions Architect at AWS.
Today we are going to talk about how Entity Docomo has used Agentic AI framework to expedite their 5G core network deployment using the Agentic AI framework. So we have been working with Entity Docomo over the last several years. And here we are some of the challenges that we have captured that Docomo has been facing in their network. As any CSP would have to deal with multiple network environments working in on-premises and in the cloud, several network functions integrated with each other from different ISVs, each of these ISVs coming up with their own documentations, user guides, troubleshooting guides, and so on, which have to be interpreted, translated to configurations, scripts, and so on. And you need an army of people with specialized skills in each of these areas: installations, troubleshooting, Kubernetes, cloud skills, and so on. And which means that each of these have to translate it into flows, and these flows would take means additional time and long lead time that is taken to deploy the overall network and so on. So we started with this problem statement and then worked with Docomo to arrive with a solution using the agentic AI solution that AWS has to provide. Amazon Bedrock is at the helm of our solution, where we use Amazon Bedrock and Agent Core to create specialized AI agents for each of the tasks that are broken down to achieve the overall flow. As you see in this particular diagram, we have created specialized agent in this particular example showing which agent which triggers a GitOps driven intent based CI/CD flow to deploy a 5G core or a UPF network function. Awais would show you what we have done in this particular demo.
So, as Sudhir was explaining about the network functions, the deployment challenge, for this particular demo, we have picked UPF, which is deployed on a bare metal outpost server. This is a BMN CX2 instance that you see on the screen. There are two Mellanox CX7 cards on this server that provide high performance networking, and we are basically using VFs on each of these cards to deploy N3, N4, and N6 interface, as you can see, in an HA fashion. We are not just deploying the network function, we are also validating the function. As you can see, there are two test servers that are deployed as well using the Agentic AI. One is the uplink traffic server, and the other one is the downlink traffic server that basically is testing whether the UPF is actually deployed correctly or not, and validating the throughput capability as well. And you can see once the system is deployed, a single instance can actually do over 360 gig of traffic with 10,000 UE sessions, both symmetric downlink and uplink, and still a bunch of CPU capacity left onto the compute server. Now moving on, as Sudhir was explaining, the core problem statement we have broken down into SOPs. What these SOPs are, these are standard operating procedures which basically define what the agent is going to do. So basically these are, think of these as prompts that are given in a standard methodical format. When the agent is going through these prompts, it's basically trying to reduce the amount of hallucination that it would do, right? Typically, that is one of the key challenges that customers are talking about, that when they use enterprise AI into network domain, the hallucination is basically something that breaks things for them. So this is the solution that we came up for Entity Docomo to reduce that kind of problem. And then just to give you an example of how the system works, I'm going to select one of the SOPs here and kick off. By the way, this is a live system running on a real outpost in a lab. And I'm going to kick this off and show you how the agent flow works. So as you can see on the screen, this central part is the strands agent, which we have created specifically for this purpose of executing. So right now it's reading this file, which is called network infrastructure, which basically validating whether the network infrastructure is actually deployed correctly or not, right? And then in the second layer, you see here the agent is exposed to these many tools, which are basically purposefully defined because of the function that it's going to execute. For example, right now this strands agent is trying to configure something on the EKS cluster, right? So it's going to pick the tool that is from the Kubernetes tool set, right? Similarly, if it is trying to do anything for the GitOps operation, it's going to pick a tool set. So think of this as a Swiss Army knife, and it's basically picking up a tool that it is required to execute that function. And finally, what we have learned from our customer Docomo is that they basically have a significant amount of benefit doing this, almost 80% in time to deployment reduction, which is a significant, and also significant amount of reduction in manual errors that tend to happen when people are doing this manually and trying to do this over and over again. So that's basically the key benefit of this demo. Thank you.